We've looked at solving quadratics before. We did factoring sometimes, we did the quadratic formula, we did completing the square. Remembering factoring sometimes works, but the quadratic formula and completing the square always work. Now, sometimes equations can be set up in a quadratic form, but they're not technically quadratic. Like the 2 down below here, they're not quadratic because they're not having a highest exponent of 2. However, it is possible they could be written in that quadratic form of something times your variable to a power, something times your variable to a power that's half of that. Notice this exponent here is double this exponent here. And then something that doesn't have that. Now, for the most part, you got to have your 3 terms for it to be quadratic. 2 of them have to have variables, and the one has to be double the other. Well, here we want to know, are these quadratics? Well, we have 3 terms over here. We have 2 of them with variables, and our 6 exponent is double our 3 exponent, so it is quadratic. So we should be able to write it in this form here. The question is, what do you end up putting in your box? Well, your box is going to be the smaller of the 2 exponents, which is a cube. So we're going to write it as a 2, and then an x cubed, all squared, and plus a 1, x cubed, and you're plus 9. Now, as you look at this part here, remember, an exponent raised to an exponent, you'd have to multiply those exponents. And when you do that, you do get your exponent of 6. So this is in the quadratic form, which means once we have it like this, we could use our quadratic techniques to solve it, like factoring or quadratic formula or completing the square. Is this one over here quadratic? Well, we have 3 terms, 2 of them with variables. However, our exponent of 4 here is not double our exponent of 3 here. So it is not quadratic. So we would not be able to use our quadratic techniques to solve that one. So we want to go ahead and look at these. Is this one here quadratic? You try it and then watch the video. Well, yes, it is. We have 3 terms, 2 with variables, and this exponent's double that one. So we can write it in the quadratic form. Remember, whatever is your smaller exponent corresponds to your box. This one over here, you might be saying it's not quadratic. Well, it really is quadratic because you could put in your missing term here, and now you have 3 terms, 2 of them with variables, and this exponent's double that one. So you could write it in the quadratic form. So we want to go ahead and solve these. If they're quadratic, we can solve them by factoring or the quadratic formula. Well, this one here is quadratic. We have 3 terms, 2 with variables, and 1 exponent that's double the other. So we could write it in that quadratic form. Oh, so now it says whatever is being squared here, that's what we're solving it for. Well, what's being squared is what's in the box, our x squared. So we could use our quadratic formula. We'll go x squared. And by the way, if you don't write what's in your box here of x squared, you'll more likely make mistakes on your quizzes and tests because you'll forget that final step. Plugging everything into your quadratic formula simplifies down, and we get x squared. Oh, I forgot my plus and minus here. I got the plus, but not the minus. So if we work this out, we add these. We get x squared to be 25. If we subtract these, we get x squared then to be 4. Now, for those people that are lazy and don't go x squared here, because x squared was what was in our box, they'll get down here and they'll say that what we have right here is your final answer. But we're trying to solve it for x. If you have what your box represented equal to these numbers, that's going to help you remember to do that last step. Here we'd have to finish solving it for x, so we'd have to take the square root of both sides, and we get plus and minus 5, and we get plus and minus 2. Here we have a total of 4 answers. Now, We have 4 answers, and our highest exponent was 4. If you're dealing with a polynomial where your exponents are positive whole numbers, your degree, your highest exponent tells you how many answers you'll have, which we had 4. Now over here, this one is not quadratic. However, it is sum of cubes. And we've looked at solving sum of cubes before. Here's your formulas for sum of cubes, differences of cubes, and differences of squares. So we could factor it according to the sum of cubes. What's being cubed here goes in for your circle things. What's being cubed at the end, which is 6, goes in for your triangles. Now we have two things multiplied together to give us 0, so we can set the first factor equal to 0, and we get 6. Set the second factor equal to 0. Oh, well, that's just quadratic, so we could use our quadratic formula to solve that. So we use our quadratic formula, we work it down, we get a negative on the inside, which means we're going to have i's in our answer, and we get this. So we get 2 answers here. Oh, my root's missing just a second. So we get 3 plus or minus 3i root 3. The 3's in front here come from taking 6 over 2 and 6 over 2. So we have 2 answers here, and we have 1 answer here, so we have a total of 3 answers, and we would expect that since we had cubes up here, with your degree being 3. So go ahead and try these two if you've not done so. This one is quadratic, so we can use our quadratic techniques. An x squared goes in our box. Use quadratic formula, remembering to go x squared equals, x squared equals, x squared equals, and we finish solving it, and we get x squared to be equal to 9, and we get x squared to be equal to 1. We take our square root of both sides, we get plus or minus 1, and plus or minus 3. We get a total of 4 answers, which we would expect when we have an exponent of 4. Now, determining how many answers doesn't work over here by our degree because it's not a polynomial. So we're not sure how many answers we'll have. It's not a polynomial because we have fractional exponents. But we can still go ahead and try to solve it. If it's quadratic, we can go ahead and use our quadratic technique. We have 3 terms, 2 of them with variables, and isn't 1/2 double 1/4, so it is quadratic. What goes in your box, remember, is the smaller of the 2 exponents. So we could go ahead and use the quadratic formula. Remember to go x to the 1/4 equals, do your quadratic formula. Now we have x to the 1/4 is equal to 3, and x to the 1/4 is equal to negative 2. We have to undo that 1/4 power. 1/4 power, remember, is the 4th root. We have to undo the 4th root, so that means we have to raise both sides to the 4th power. Same idea over here. Raise both sides to the 4th power to undo that 4th root, because the 1/4 power is a 4th root. Now, a second way you could think of it is when you multiply these exponents, we need to get an exponent of 1. And a 1/4 times what is 1, and that's 4. Now, when you raise both sides to an even power, you should technically take these answers and plug them back into the original to see if they work. And if you go ahead and try the 81, 81 is to the 1/2 is square root, which is 9. To the 1/4 is the 4th root, which is 3. 9 minus 3 minus 6 is 0, so it works. Try 16. So this would be the square root of 16, which is 4. 4th root of 16, which would be 2. So 4 minus 2 minus 6 is not 0. So the 16 does not work. Your only answer is the 81.